If you have little or no experience using music software to play and record music, then this tutorial is for you. In this video, I'll explain some of the terms and the concepts that you need to know to use music software. You can get more help in other aspects of the Cakewalk by BandLab program by using the Help menu and hovering over certain areas within the software, as shown here. Throughout this tutorial, I'll use the term DAW or DAW. This stands for Digital Audio Workstation. This is the software that we're talking about, specifically the Cakewalk by BandLab program. The basic way that you use a computer to record and play sound is this. Your computer has a circuit board in it called a sound card, which converts the sound from an electric instrument or microphone into a long string of numbers, which a computer then stores and converts back into sound when you want to play that recording. Almost every computer comes with a sound card which is good enough to make very good, but yet not fully professional level recordings. The sound card has inputs and outputs on it, which you can see by looking at the back of your computer. To record, for example, an electric guitar into the computer, you plug one end of your guitar cable into your guitar and plug the other end into the line input of your sound card. Then, you would click the record button in your Cakewalk software, start playing your instrument, and then click the stop button or press the spacebar. The line input has a little icon next to it which is very hard to recognize, so it usually helps to look at the documentation that came with your sound card or computer. A guitar cable has a plug on it that is a 1/4 inch wide diameter, and the line input on low-priced sound cards is a 1/8 inch wide. Therefore, you need to connect your guitar cable to a 1/8 inch adapter in order to plug it into most sound cards. These adapters are inexpensive, and they're also very useful to have laying around. Now, if you want to record an acoustic instrument or a vocal, you would need to use a microphone. You connect the microphone's cable to the adapter and plug the adapter into the mic input of the sound card. However, you could get a better sound by plugging the microphone cable into a preamp or a mixer with a preamp, and plugging the outputs of the mixer or preamp into the line input of the sound card instead of the mic input. You would then need an adapter to connect the two outputs, left and right, of the mixer or preamp to the 1/8 inch line input. Be sure and ask the store where you buy your preamp or mixer what kind of adapter that you need to connect a sound card that has 1/8 inch inputs. Professional quality sound cards, however, do not use 1/8 inch inputs, so you do not need one of these adapters to use a professional grade sound card. To play back the music, you need to connect powered speakers or headphones to the output of the sound card, which on new computers is usually painted green. Then, you click the rewind button or press W in your Cakewalk software, and then click the play button or press the spacebar to play back what you just recorded. Music software uses two different formats to play and record sound, MIDI and audio. Knowing the difference between these two formats is essential for using music software. As previously stated, the audio format works by converting any sound that's recorded into a long series of numbers, storing and usually editing those numbers, and then converting the numbers back into sound. When you record sound using this format, the microphone you use causes the voltage in its cable to change rapidly as the mic's diaphragm vibrates. These rapid changes in voltage are measured and recorded by an analog to digital converter, and these measurements make up what we call digital audio. To convert digital audio back into sound, a digital to analog converter uses the stored numbers to cause the voltage in a cable to change rapidly, and then this voltage then moves the diaphragm in a loudspeaker in a similar way to that of the microphone's diaphragm moved originally, unless the numbers have been edited to produce a more desirable sound. These converters, commonly referred to as A to D or AD and D to A or DA, are part of your computer's sound card. Better sound cards usually keep their converters in a separate box that's not in the computer itself, because the computer's fan and disk drives can actually add noise to the sound card signal. Digital audio works like cartoon animation. In a cartoon, a series of still photographs is displayed very rapidly in sequence to make it look as if the objects in the photographs are actually moving. When digital audio is converted back into sound, the voltage is changed at regular intervals to simulate continuous sound. To make high-quality sound, the original voltage during the recording has to be measured or sampled at rapid enough intervals to fool your ears into hearing continuous sound. For example, audio CDs use a sampling rate of 44,100 samples per second. Now, to store and edit so many numbers places a huge load on most PCs, a much bigger load than the processing of MIDI data. Let's talk more about the term MIDI. MIDI is short for Musical Instrument Digital Interface. MIDI is a system that lets an electronic instrument or computer control other instruments. MIDI basically is a large set of commands called MIDI messages that causes an electronic instrument to play specific sounds at specific times, and also to play those sounds in the style that you dictate. A MIDI instrument functions very much like a player piano, only instead of using a roll of paper with holes punched in it, a MIDI instrument needs a software program or other MIDI instrument to turn its notes on and off. One common misconception with MIDI is that MIDI is sound, when in actuality, when you record MIDI, you don't record the sound of the instrument that you're recording. You simply record the commands that play the instrument in the way that you want it played. For example, when you press a key on a MIDI keyboard while your Cakewalk software is recording, the software just records the fact that a certain note was pressed and then released. The software doesn't record the actual sound of the note. When you play back the recording, the software then takes control of your MIDI instrument and turns that note on and then off at the same time in the song that you did. Because MIDI is more information rather than the sound vibration, MIDI notes can actually be read and displayed by a music notation program. Digital audio, the sound format used by CDs, WAV files, and MP3s, cannot. After you record your MIDI data, you can use Cakewalk to convert the MIDI data into digital audio so that you then can create CDs, MP3s, or Windows Media files. MIDI has advantages and disadvantages when compared to digital audio. MIDI files are much smaller than audio files, since MIDI data is only made up of the commands to play the instruments, instead of the actual sound of the instruments themselves. Because of this, MIDI files take up a very small footprint when it comes to hard disk drives. You can easily email MIDI files, and you can save a MIDI file in a format called a standard MIDI file, and then open it and use it in many different programs. You can record MIDI music as slowly as you want, and then change the tempo in your software to play it back at any tempo that you want. Conversely, audio files can only play back at approximately the same tempo that they were recorded at without drastically altering the sound quality. It's easy to edit and transpose MIDI files since they're so small and you're just editing commands, not actual sound. Another added benefit of MIDI is that MIDI files can be printed out as standard musical notation or lead sheets. One of the major drawbacks to MIDI is that it can be harder to make MIDI music sound as natural as audio. If you don't record MIDI music in real time, it can even sound somewhat mechanical. Some MIDI instruments, especially some of the acoustic sounding instruments, such as brass, strings, and guitars that you find on the built-in synthesizers of low-priced sound cards, can actually sound artificial. However, percussive sounds usually sound quite good on MIDI instruments and are much easier to record than a real drum set. You can also play back MIDI data through any number of hardware or software samplers that use recording or samples of any instrument you can imagine as sound sources. I hope that you found this brief introduction to digital audio recording helpful. If you did, leave a thumbs up and go ahead and subscribe while you're here. That way every time I release a video, you'll be the first to know. Thanks, and until next time guys, I'll see you later.